All right, so we're putting it all together here. Last page, let's conclude our study and figure out which car was the fastest from 60 miles per hour to 100 miles per hour when they tested it at Car and Driver. So which one did accelerate the fastest? Remember, that's going to be the one with the largest acceleration. So we had a 9.09 here. Okay, this ended up being the slowest. We've got 10.81 and we have 10.53. So 10.81 is the winner here. That tells me that the BMW M8 is the fastest. So the BMW M8 accelerated fastest. Okay, how does the answer compare to your original guess on page 1? Now, this would be based on whatever your guess was, but for me, my guess was Audi, and so that's why I put this nice picture of the Audi, because I just think they're awesome. But anyway, it was the second best, right? And it was close. 10.53 is close to 10.81. All right, 3/10 of a acceleration point off. It was definitely a lot closer than this one. This one was almost 2 miles per hour per second lower than the winner, BMW. So at least I came in close second place instead of far third place. So that was comparing. I was surprised. I really thought that the Audi, it just looks fast, right? It just looks fast. I don't know. Maybe it's the red. Okay. Maybe if they were all red, I wouldn't think it looks faster, but that was just my opinion. Again, this answer is going to be based on how you guessed on the first page. Last thing, describe how you find the average rate of change. So for any data point, okay, given set of data, if you're given a table, if you're given a graph, if you're given an equation, we're going to look at all of these in the next lessons or so. We're going to continue to look at average rate of change. How do you find average rate of change? Find average rate of change. Okay, let's talk about it. Okay, to find average rate of change between two coordinates. Okay, find the change in y values over the change in x values. Okay, and that's it. Okay, change in y over change in x. Find the slope. All right, slope is the change in y over the change in x. Right, rise over run. Okay, whoever is changing y's quicker at the same time that the x's are changing is the winner when we're talking about who's increasing the fastest. Who's decreasing the fastest will be the same thing. Whoever's y's are going lower quicker. Let's see if we could have determined this just looking at the graph. So we know now that the winner was the BMW. Could we have seen that from the graph if we understood how to read it? Let's look at the graph again. Okay, so let's look at where BMW was. BMW was the purple. How would we have known that it was accelerating the quickest? Well, if you take a look at where its points are, okay, so its first point is here, right? This point is further to the left. What does that tell me? That tells me that it took less time to get to that speed, right? It took less time for the BMW than for the other two to get to that speed. It only took the BMW 2.6 seconds. It took the Audi 2.7. It took the Mercedes 3.0. So in order to get to 60, it was the quickest. But even after 60, look at it's 100. Look at where it's 100 is. Again, it's furthest to the left. That means that it has the fewer seconds. So it didn't take as long even to get from 60 to 100. And look at where Mercedes is. That's why it was such a bad loss for Mercedes, why they were so far lower than the BMW. If you take a look at the graph, it took way longer for this Mercedes to get to 100. Okay, almost what? 0.5, 0.75, 1, 0.25, almost an entire second longer, right? Almost an entire second longer. It took 7.4 seconds, and the BMW it took more than a second longer, right? BMW only took 6.3, the Mercedes took 7.4. So it took even longer than a second, which seems like nothing, right? 1/1000, that's a second. But when you're talking about cars going at fast miles per hour, a second is a long time. I mean, they get far in a second if you're going this fast. So a second is actually a big deal. And this gap was crazy. If you notice, the blue line is flatter than the red line. And the red line is just a little bit flatter than the purple, especially in this part here from 0 to 60. Okay, you can really see that that purple line is more tilted towards the top versus the red line is a little bit flatter. But between 60 and 100, they're almost the same. And that's why, again, we got very similar values for the BMW acceleration and for the Audi, because between 60 and 100, they were pretty close to each other. All right. These lines are almost parallel to each other. So it looks like they're almost going at the same rate, but the purple line is a little bit steeper. And the BMW just accelerates a little bit faster than the Audi. So that's how you found average rate of change. And you guys are going to get some time to work on homework and next lessons. So I will see you in the next lesson.